talk too much, that's fine. Okay, so if you just want to look at that function as x squared minus x plus 1, just to see how it looks and see why we shouldn't plug in anything in it. So go to zoom 6 and graph it. We'll never touch the x-axis. Will always be positive. Don't bother with it. Okay? So coming back here, don't plug in anything in this piece. It will be a waste of time. Anyway, yes, I got it. So, negative 2.1 sine. No, that's not good because we can't see. With negative 2.1 sine. Negative sine. Sine. 3 negatives. Good. With negative 1.9. Negative 1.9. Negative 1.9. But negative 1.9. Negative over negative. 2 negatives. Perfect. Negative 0.1. Negative 0.1. Negative 0.1 plus 1. Negative 0.1. And negative 0.1 plus 2. 1 negative. Finally, with 0.1. 0.1 plus 1. 0.1. 0.1 plus 1. Plus 2. Very good. Perfect. Good. Please, you cannot plug in 0 because it's a vertical asymptote. But please tell me when is the numerator 0, knowing that this is never 0. Make sure that you place it correctly between negative 2 and 0. That's where the x-intercept is, the y-intercept. I'm sorry, yes, the x-intercept, right? It was negative 1, y 0. Good. So now I need the end behavior. What do I need to do to find the end behavior? Since it's type 3, what do I need to do? Divide, in this case, using the long division, x cubed plus 1 over x squared plus 2, x. So then the answer will be, the quotient will be what type of expression? Yes, it will be a line. That will give us what? The slant asymptote. Very good. So let's take it aside. Since they are both in descending order, but I look at x cubed plus 1 and I know it has some missing terms. And the missing terms are squared, then x, and then plus 1. X squared needs to be multiplied by what to give us x cubed? Very good. So now I distribute. X times x squared. Yeah, but I have to lie and change the sign. X times 2x. But I have to lie and change the sign. I bring down the next in line. And plus 1. Final question. If this is degree 1, the next one has to be degree 0 and I'm done. I cannot go back to something else. X squared gets multiplied by, or negative 2x squared. And the top I cannot lie. Negative 2. Now when I write underneath, I lie again. Negative 2 times x squared is negative 2x squared. I have to change the sign. Negative 2 times 2x is negative 4x, but I have to change the sign. And what is left is 4x plus 1. Can I continue? No. X squared times what is 4x? No. So what is the quotient? Because that will be the slant asymptote. So y equals x minus 2 is a slant asymptote And now I have to identify the end behavior based on this line. Does it have a positive slope? If it does, then the end behavior is this. If it has a negative slope, then the end behavior will be this for the function. So what is it? Positive. So then what is the end behavior? But yes, negative infinity to positive infinity. Okay, let's analyze this. It makes no sense, right? Really makes no sense. Very easy though. Okay, so let's look at this. Is that clear? It's coming from negative infinity, but on the left-hand side of the first asymptote, it will go back to negative infinity. So it has to look like this. So that's this piece. Let's see what happens here. From positive infinity, it crosses at negative 1, 0. It goes to negative infinity on the left-hand side of this asymptote. Okay. Positive infinity, crossing at negative 1, 0, and going towards negative infinity. No problem. Here it makes no sense. Yeah. No problem. From positive infinity, going back to positive infinity. When I graph a function with asymptotes, what do I have to graph first? The asymptotes. Let's start. Negative 2. 0 is an overkill because it's already there. But how do I graph y equals x minus 2? When x equals 0, y is, when x equals 0, y is negative 2. And when y is 0, bring negative 2 to the other side. 2. Okay, back to the chart. From negative infinity approaching the slant asymptote, back to negative infinity approaching the vertical asymptote. Ready? Here it is. Does not touch anything. Okay, now in the middle. Negative 1, 0 is here. Negative 1, 0. From positive infinity, crossing and going towards negative infinity on the left-hand side of this asymptote. The other side is clear too. Here it is. It has to approach the vertical asymptote, and it has to approach the slant asymptote. I have to determine this point, and I have to determine this point. Let's see. So in y equals, clear. Don't forget parentheses around the top. X cubed plus 1 divided by, don't forget parentheses for the denominator, x squared plus 2x, close the parenthesis. What else I need to put in there, because the calculator is not as smart as you are. Very good. X minus 2. Awesome. Indeed, x minus 2. Now I'm thinking about the viewing window. I really don't know. I have that little feature in this software, so I'm going to say standard for now. Zoom 6. Here it comes. Now, with the standard viewing window, I see two flaws, two problems. Of course, you cannot stop here. I know that. If somebody copies this from the graphing calculator, I know what. Right. So please don't copy something like this. Please don't copy something like this. This is lying to us. I don't really care because we already know the graph, but what I really care about is this point and this point. So I want the minimum between 0 and 2. So second and calc. You cannot put in 0, however. So I want the minimum. So minimum is 3. You cannot put in 0 because it's undefined. I'm going to say 0.2. And I'm going to say 2. And no, I don't want to guess. Just give me the minimum. Don't torture me. So it's at 0.92, 0.66. Between 0 and 2. So 0.92, 0.66. And now I want to find this point, which is the maximum. So negative 1, 2, 3, 4, somewhere around 4. So I'm going to say between negative 6 and I cannot put negative 2. So negative 6 and negative 2.5. So second on calc. And I want a maximum, which is 4, between negative 6, enter, and negative 2.4. Good. I see it includes the maximum, so it's not, I don't want to guess. So the maximum is at negative 3.9, and the maximum is negative 7.87. So on the other side, I put negative 3.9 and negative 7.87. Now I know absolutely everything about this function. And this is type 3. Any questions for me? Any questions? Any questions? Okay, the last section that we need to cover is 3.6, and it deals with, and I expect you to solve as many problems from these between now and Wednesday so you can ask questions. This is when you check your understanding of everything. Okay, please do. Okay, last section is section 3.6. And it deals with polynomial and rational inequalities. Polynomial and rational inequalities. So let me give you a couple of examples and of what we are trying to do. Because we know a lot of inequalities. We know linear, we know with no absolute value, but these are more sophisticated. Polynomial. Okay, so here's an example of a polynomial inequality. You can say, but the left-hand side is not a polynomial. It is if I distribute it. What would be the degree on the left if I were to distribute? I don't need it. I want it like this. It's degree 3. So this is not a linear inequality. It's not even quadratic. But quadratic or polynomial will be solved in the same identical way. Okay. How many factors again do I see on the left? Factor number 1, factor number 2, and factor number 3, correct? Okay. I accept any method. I will recommend the following one, but it's up to you. Okay? When is the first factor 0? When is the first factor 0? When x is? Of course. When is the second factor 0? When x is? Positive 1. Very good. When is the third factor 0? When x equals? Negative 4. These are the only numbers I need in the chart that our table that I will show you. So x is the variable in the problem, and it goes from negative infinity to infinity. All 3 factors have to have their own row. You told me that the first factor is x. Was x? Its first, its own row. The next row is negative x plus 1. The next row is x plus 4. What will be the last row? the whole thing, right? So I take it by piece by piece. I study what happens to x. I study what this one does, and I study what this one does. But I'm not interested in those pieces. I'm interested in putting everything together. So the last row is everything together. So the last row is x multiplied by negative x plus 1 multiplied by x plus 4. Now the numbers that go in the chart, you already gave them to me. So please give me in order. Very good. You said negative 4, then you said, and then you said, very good. Let's analyze the first factor. Where is x 0? Because that's where I have to put the 0 for it. Where is negative x plus 1 0? And where is x plus 4 0? Perfect. So now, tell me what happens when x is negative 4 to the whole thing. Correct? So what would the answer be?
0.
Of course, because one of the factors is 0. Very good. What happens when x is 0? Right, because another factor is 0. I don't care what happens to the other two if one of them is 0. Awesome. And what do I write under 1? 0 for the same reason. Okay, now please bear with me. I know I look silly, but maybe this will help you. This is what type of function? Awesome. Does it look like this? Or does it look like this? Number 1. Number 1. Which values does it come from? Which values is it going to go to? And somewhere it crosses the x-axis. Somewhere it's 0, right? Okay. So it's negative before it's 0, and it's positive after 0. That's the sign. Okay, next factor. What type of function is this? The next factor. Perfect. Does it look like this? Or does it look like this? Second. So which values does it come from? And which values does it go to? And somewhere it crosses the x-axis where it's 0. Very good. Last one. Please tell me the sequence of signs. That's it. How many subintervals we see here? 1, 2, 3, 4. Count the negatives on the first subinterval and tell me the answer. Exactly how we did with the the behavior left and right. Count the negatives and tell me the sign when you multiply these 3 numbers on this interval. On this interval. On this interval. And on this interval. Good, because we multiply them. I multiply a negative by a positive by a negative. I multiply a negative by a positive by a positive. Are you with me? Okay, finally, I'm asking myself, what do I pick? What is less than or equal to 0? Which sign will be less than or equal to 0? Right. So now I'm looking at the last row. I don't care about the rest. I'm only interested in the last row. Is this last row ever negative? For which x values? Union. For which x values? That's it. So x in the interval, -4, 0, union 1 to infinity. I made an error. There is an equal symbol. So I have to put brackets everywhere. Except infinity. This is how we handle a polynomial inequality. I would like you to pick a rational one. Page 441. Page 441. From 43 through 60. Which one? 50. Very good. 50. 3x plus 5 divided by 6 minus 2x greater than or equal to 0. We have to write a very important note before we start. But first I want to ask, what type of inequality is this? Is it absolute value? Is it linear? Is it quadratic? Is it polynomial? No, none of the above. We discussed this function. What function is this? Rational. That's why this is what type of inequality? Good. So the note that we have to write, which is extremely important, we cannot multiply both sides of an inequality like this by 6 minus 2x. Do not try it. Why? How come I cannot get rid of this denominator? Why? No. Okay. No.
Because it's all.
No, you're right, but not because of that. Now, if I hold on, if I have this, can I multiply both sides by 6?
Sure.
Of course, it's not going to change. It's not going to change anything, right? I can multiply by 6, but I have 6 minus 2x. Can I multiply both sides by 6 minus 2x? No. Why? No. So that's it. So I don't know if this quantity is or. So I don't know when to switch the symbol. If you tell me 6 minus 2x is always positive, then I'll get rid of it. But if you say 6 minus 2x can be anything, I cannot get rid of it. So we have to write this down. Note. Never multiply or divide both sides of an inequality by an expression containing what? Containing, sorry. Containing, okay? Yes, x or the variable. And now I have to be correct and put in parentheses, unless you're told that that quantity is always positive or always negative. So how do you want me to write it? Unless you have information about the quantity, okay? Unless we have info on that quantity. I have to be exact. If you tell me that 6 minus 2x is never 0 and always positive, I'll say fine. Then I can get rid of it. So I put this portion in so you know that in certain conditions, I may do it. But in general, do not. Okay, good. So how many factors we have to put in our chart? The same table, same idea, everything the same. How many? X is the variable in the problem. So how many factors we see here? Yes, the first factor is 3x plus 5. Always keep them in descending order so you don't make a mistake. What is the second one? Negative 2x plus 6. Always keep them in descending order so you don't make a mistake. And what would be the last row? Exactly, the whole thing. That's what I'm studying. I don't care for the pieces. I care for the whole thing. How many x values will you give me to put in the chart?
Why did we change negative 2x plus 6?
Because everything has to be in descending order so I don't make a mistake when I analyze the sum. Very good. So, ready? What will this need? Set it equal to 0 and tell me what you get. Yes, please. Very good. What will this be? Because I need both before I put them in because they have to be in ascending order. 3 indeed, right? Negative 2x equals negative 6, x equals 3. Very good. So this is the correct order. Negative 5 over 3 and 3. Are you with me? Yes? I set the equal to 0 and I moved 5. It becomes negative 5 and I divide it by 3. Is that good enough? Yes, everyone? Do I have to write it? Yes? Yes. So 3x plus 5 equals 0, 3x equals negative 5, x equals negative 5/3. That's okay. That's okay. I know it's late. No. You have to set it equal to 0 to find the x-intercept. Good. So 3x plus 5 has a 0 somewhere. Where? Under negative 5/3. Negative 2x plus 6 has a 0 somewhere. Under 3. What happens to the fraction when x is negative 5/3? Very good. What happens to the fraction when x is 3? Ah, 0 is not undefined. Do we understand why when x is 3, the expression is undefined? Yes? Exactly. So what we learned before doesn't go away right now. Okay, so please dictate the sign for the first one. Awesome. Please dictate the sign for the second one. That's why I arranged it in descending order. For you not to make a mistake. Exactly. Positive till it gets to 0 and then negative. Awesome. The division will have what sign on the first subinterval? Very good. On the next subinterval? Very good. On the last subinterval? Good. I'm done, but I have to look now and see what I am asked to find. What sign is greater than or equal to 0? What am I looking for? Good. Is the entire thing ever positive? For which values of x? So x in the interval, negative 5/3, comma 3. It was greater than or equal to, I made the same mistake again, but I cannot include 3. Do you agree that we cannot include 3, even if the inequality has the equal symbol in it? We agree? Yes, because the expression is undefined. Good, this is it. So now please choose whatever you want. My department said to choose between 3 and 51 and then 77 and 93. Feel free to choose anything you want. This is it. Yes, please. Shannon? Because it's equal to 0. It says greater than or equal to 0. So here it's 0. So I have to include negative 5/3. It's undefined. Yeah, because it's undefined. Which 77, where is it? Okay, use the given function at the bottom of the previous page to find the stopping distance on dry pavement. Okay, so we have to go back. So we have functions. The function for the dry pavement, f of x equals 0.0875 x squared minus 0.4x plus 66.6. Okay, so it's on page 441, so that's 77 on 441. So forgive me, I should have written it myself. Use the given function at the bottom of the previous page, which I copied for you, to find the stopping distance on dry pavement and the stopping distance on wet pavement for a car traveling 35 miles per hour. Okay, so they want the other one too. So this is on dry, and g of x 0.0875x squared plus 1.9x plus 11.6. I'm sorry? Yes, I'm sorry, forgive me. So this is 0.0875x squared minus 0.4x plus 66.6. And this one is 0.0875x squared plus 1.9x plus 11.6. So let's see what we are asked to do here. Part A, use the given functions to find what is the distance, the stopping distance when x is 35. So x f of 35 and g of 35. So this will be part A. Based on our answers in part A, which rectangular coordinate graph shows stopping distances on dry pavement and which shows stopping distances on wet pavement? We have to look at the graph after we find these numbers. How well do your answers to part A model the actual stopping distances shown in figure 3.43 on page 431? Ooh, I should go back to page 431. You know. Why do you even ask? Why do you even ask? Okay. There is a table. That's fine. Determine speeds on dry pavement requiring stopping distance that exceed the length of 1.5 football fields or 550 feet. Round to the nearest mile. Okay. So, in order to find these, you put in the graphing calculator. This is what I would normally do. So, in y equals clear. So I would put in 0.0875 x to the second power, and then minus 0.4 x plus 66.6. It's actually a very good and interesting problem. We will learn something from it, I'm sure. So 0.0875, but we should ban him, that's for sure. Plus 1.9. He did that though, to us all the time. And plus 11.6.
Look, you take it up with your department chief.
I agree. Okay, so in second and table, I will plug in 35. And when I plug in 35, I get both answers at the same time. So the first one, which is on dry pavement, 159.75 feet. For 79, I'm sorry, 79 feet. And the other one, 185.29 feet. Perfect. Now we're ready for part B. Based on your answers in part A, which rectangular coordinate graphs show stopping distances on dry pavement and which stopping distances on wet pavement? So the graph at the top of the page looks like this. And somewhere here I have 35 miles per, I'm sorry, forgive me. Somewhere here I had 35 miles per hour. So which will be this and which will be this? Which function is the top one? Which function is the bottom one? Bottom one is the f of x, and the top one is g of x. Can anyone explain? Exactly, because this distance is 159, and this distance is 185. Good. Are you with me, everyone? No. So this is 159, so this must be the first one. And this is 185, so it goes higher. So this one must be g of x. Is that okay? Very good. Part C. How well do your answers in part A model the actual stopping distances, blah, blah, blah. So I'm going back to that graph on page 431. And we're asked to say if the model is good for the actual data. So for 35 miles an hour, the green dry pavement is 160 feet, and for 35 miles an hour, the other one is on wet pavement, 185. So the actual data gives 160 feet for this and 185 feet for this. What will you say about the two models?
And the actual question said to ground is the
And it also probably said that too.
that's not on.
Are you happy with the model at 35? I don't know at 40. I don't know at 60. I don't know at 90 if the model is still true or good approximation. But at 35, would you be happy with this model?
Yes.
Yes, I would be too. I would say it's a good approximation. Last part here. Determine speeds on dry pavement requiring stopping distances. This is where the inequalities come in. Determine speeds on dry pavement requiring stopping distances that exceed the length of 540. So if the stopping distance exceeds 540, if it says exceeds, I will not put the equal symbol. So f of x greater than 540 and g of x greater than 540 feet. Let's read it one more time. Determine speeds. X, in other words, determine x on dry pavement requiring stopping distance that exceeds the length of 540 feet, round to the nearest mile. So they're not asking us for G. They only want us to do the F. So this is not required. You can do it if you want later. But they're asking us to solve this inequality. What is my first step? So this is my C was that we were happy, and this is D. What should I do to solve this inequality? What is my first step? Replace f of x. This is just a name. This is not an inequality per se. I have to replace it by 0.0875 x squared minus 0.4x plus 66.6 minus 540 greater than 0. So we have to write one more note. I have to get rid of this. The previous tables or charts we used require two conditions to be fulfilled. Condition number one. The previous charts we used require two conditions to be fulfilled. The first condition, 0 must be on one side and nothing else. 0 on one side. Mandatory, 0 on one side, not a number or x or anything else. Number two, the second condition, on the other side, not the 0 side, on the other side, a product or ratio. If I don't have a product or ratio on the other side, I can't solve the problem. And if I don't have 0 on one side, this is a mess. I do have 0 because I moved 540 to the other side, but this is far from being a product. I cannot make it into a ratio, of course, but it's far from being a product. So first I'm going to divide by this number and see what happens. Of course, combine these two first and then divide by this number. Maybe it becomes a little bit more human. Maybe. So let's write it first, 0.0875 x squared. If after I clean it up as much as I can, it's not factorable or I cannot find the solutions, I have to use the graphing calculator to find the solution. See, the examples I gave you were user-friendly. But these are not encountered in real life all the time, right? This is a real-life situation. That's why this is a good example. So here, I didn't have to worry about factoring or finding solutions. It was very easy. But here it's a different story. So first, I have negative 0.4x, And then 540 minus 66.6 is negative, it's 0.4, right? And 6 from 9 is 3. And what do I have? 6 from 53? Right?
473.
Yes, that's what I... Good, very good, thank you. 473.4, correct? I'm going to try and get rid of this and see if anything nice happens. If I get lucky, something nice will happen. So I will have x squared minus 0.4 divided by 0.0875. Awful. I wouldn't. I wouldn't because it's a irrational number, and then I will approximate. So I tried. That's okay. Well, I have no choice, but I have to put in the graphing calculator. There is no other way. In y equals, I already have this function. I'm going to delete the other one. So the function is there, but I have to make the change because it's 0.0875 x squared minus 0.4. That's correct. But then I have to change this into negative 473.4. Thank you very much. Good. What type of function is it? Because I have a lot of worries here. I don't know where the viewing window should be. But what type of function is it? Let's analyze this. It's a parabola. We're talking about speeds. So do I worry about the left-hand side of the y-axis? No, I cannot drive at -5 miles an hour, right? So I'm going to worry about the right-hand side. Do I worry about the negative side?
Not unless you're the crash test institute.
No, wait. So we're talking about, it's a very good point you're making. So I need to worry about the negative side because this is not the function. This is the minus 540. Okay? And I want to determine when it's above the x-axis. So if you want, it's because it's greater than 0. So if you want, you can say, well, I don't really need to care. I don't really care about that side because I'm asked to determine for which speeds is this greater than 0. So I would have to agree. We don't care about the negative side. Just a little bit to see it. So I'm going to say -2 to definitely way more than 35 I should see because we already looked at 35 and I don't know what happens in there. So I'm going to say to 120 miles an hour. Not possible, I would say, but never mind. So with a scale of 40. And y minimum, I'm going to say -4. And y maximum, I don't know. I'm going to say 50 with a scale of 10. And let's see what happens. Nothing happens. Finally something happens. So I don't see this graph, right? So it has to have a minimum, definitely. It has to look like this because it's quadratic. But it's not very clear. So I'm going to go back to the viewing window. Standard viewing window is not going to work. Right? I could find a minimum first and see where it is. But definitely the standard viewing window makes no sense. So let's go back to -4 to 20, -50 to +50 with a scale of 10. I would normally do a little bit more investigating. I would find a minimum and then take it from there because -b/2a will give us the minimum, right? -b/2a, comma, the function value at that point. Because otherwise I'm just going in the dark. I don't know where the minimum is, and it's difficult for me to figure it out, where to graph. Okay.
I think it might be just at least be negative 473.4.
Ah, it's coming. Say just a little piece here, so I have to go further. Okay. I'm in the dark because I should have determined the minimum. Okay, now, okay, I see what happens here. So although we don't need a negative side, I'm going to show both because we want to see the parabola. My maximum, that's fine. Okay, here it is, finally. That's why the preliminary calculations are always useful. Okay, so now I'm going to go to the viewing window and go to a little bit higher with the y maximum. I'm going to say to 20. So we can see the entire parabola. Okay, I want it a little bit more. Okay, so I see the parabola. Of course, I'm not interested in negative velocities or speeds, but for which x values will for which speeds, which are the x values, will on dry pavement, will a car need a stopping distance of more than 540 feet? Well, obviously, between this point to the right. If the speed is this, or this, or this, or this, or this, or this, the function is above the x-axis. It's positive, which means if I choose for this speed, I will need, if I am driving at this speed, I will need more than 540 feet to stop on dry pavement. But if I drive at this speed, I will not need more than 540 feet. I will need less. If I drive at this speed, this is what I need. I need to find this x-intercept. So I go to second and calc again, and this time I'm going to choose the 0 or x-intercept 2. So I'm going to say, well, it's between this and this. Or you can say it's between this and this. That's fine too. Okay, so I'm just going to go to the right. Let's say this is my left bound. I'm going to continue till I pass. I'm going to say enter. And I'm going to press enter again, and it will give me that speed. So if I drive at 75.875 or more, I would definitely need a stopping distance of more than 540. So beyond this. Okay? But we couldn't do it with the chart that I showed you because we couldn't factor the left-hand side. We couldn't find solutions. We had to do this. No one could have found that solution of x for x greater than 75.875 miles per hour. We had to do it with the graphing calculator. The difficulty was that I was lazy and I did not find the minimum. And it took me 3 minutes to figure out the viewing window that showed the entire graph. But I know that for a speed that is greater than 75.875, on dry pavement, we need more than 540 feet. Thank you for staying.